so I know you guys are going to hate me, but this is the only way for me to get this whole problem in because application problems are just messy and long, okay? So you're going to need to pause the video and write down all this information, and then I'll talk about it. Okay, so this is modeling a tide cycle, and it says the figure below shows the depth of water at a boat dock and how it varies with the tides. So at low tide, the water is 5 feet deep, and this occurs at 4 a.m. And at high tide, it's 13 feet deep, and this occurs at 10 a.m. So they give you a graph, and they say that the y-axis tells you the depth of water, and the x-axis tells you the hours after midnight. All you need to do is turn this graph into an equation. So just like I said in the video before, you're turning this data into something that you can use to model the tide. So if we look down here, we need to find 4 different things. First of all, we need to find A, the amplitude. So if we look, we can see that the center of our graph is right. Well, I should do it in blue because it's our vertical, we actually find a vertical shift here, okay? Because our center is at 9, so that tells us our vertical shift. So 9 feet. And then our A, we can see, is from the center up to the top and bottom of our waves, which is going to be 4. So here's another tricky part. We need to figure out our period, or the B, and that's the number that affects the period. In the last example, I told you to work a little equation. So I'm going to do that little equation down here. So finding B. I said to do 2 pi over B equal to whatever your new period length is. So if we're looking over here, how long does it take before it starts to repeat? Well, with sine, we start here. So we go up and down and back around. So it looks like, my graph isn't very good, but this is actually 22 over here. So it looks like we're going to have to do some estimating if we go from here to here. So instead, even though this is sine, we're actually going to just look from any given point to another point, ones that are actually given to us. So you can see that it repeats itself from here to here, 4 to 16, that's 12. So our new period length is 12. That kind of makes sense, half a day, that's how long it takes before the tides repeat themselves. So now let's figure out what this B is. Just solve this equation, multiply by B on both sides to get B out of the denominator. Now we have 2 pi equals 12B. Divide by 12, and we get B equals pi over 6. Alright, so now we just have one more thing. We need to find C. Now remember, C affected our horizontal shift. So we need to look into our graph and see how much was this shifted from the origin, from x equals 0. So the start of our sine function is actually way over here, halfway between 4 and 10. So what's halfway between 4 and 10? That's 7. That's actually where the start of our sine function is. So our horizontal shift was 7. And we found that right here. Okay, so we can't just say that's our C though, because if you recall, horizontal shift is C over B. So that means we need to set up yet another little equation. Our horizontal shift, or 7, equals C over our B. And we just found B. It's pi over 6. So now we need to solve for C. To get rid of pi over 6 in the denominator, we're going to multiply by pi over 6. Multiply by pi over 6. So C equals, put 7 over 1, multiply my fractions, pi times 7, 7 pi over 6, and that's my C. So as you can see, it's just a matter of analyzing the graph, setting up these little equations. For A and D, you can really just look at the graph. But to find B and C, since those two involve equations to get your result. You need to take your result and solve for the unknown variable. And there we have it. So now we can write our equation. Y equals a sine of bx minus c divided or plus d. And that's it. Okay, so now your practice problems. I'm not going to give you a modeling problem, but I am going to ask you to graph a vertical shift. So let's do this in our warm-up since we don't have room here. Let's do y equals 2 cosine of x minus pi over 2 plus 3. Good luck, and we'll go over it tomorrow.